Problem number 23. A flywheel with a diameter of 1.2 meter is rotating at an angular speed of 200 revolution per minute. Here we have to answer for four subdivisions. The first question is, what is the angular speed of the flywheel in radian per second? And the second question is, what is the linear speed of a point on the rim of the flywheel? And the third question is, what constant angular acceleration? And this angular acceleration should be in revolutions per minute square. So we have to give the answer in terms of alpha in revolution per minute square. So what constant angular acceleration will increase the wheel's angular speed to 1000 revolution per minute in 60 seconds? And the last question, how many revolutions does the wheel makes during that 60 seconds? So here, let's we answer the question one by one. First of all, let's we write the given first. So what is given here? The flywheel diameter is given. So the value of the diameter of the flywheel, so diameter D, which is equal to 1.20 meter. From the diameter, we can easily find the radius because the formula for radius R, which is equal to diameter divided by 2. So 1.20 divided by 2, we got 0.6 meter as the radius. Clear? And this flywheel, it has the angular speed. That means omega I. The initial angular speed of the flywheel, omega I, is given as 200 revolution per minute. So first of all, let's we answer one by one. So what is given in the first question? What we have to find in the first question? We have to find the angular speed of the flywheel in terms of radian per second. So you have to see the given. Here the angular speed omega I is given in terms of revolution per minute, but they need the answer for the first question in terms of radians per second. So what we have to do for finding the answer for the first question, I have to convert this revolution per minute to radian per second. So what we have to do, we have to use the rule 1 revolution, which is equal to 2 pi radian. And also we have to convert minutes to second. So we know 1 minute, which is equal to 60 seconds. Clear? So I have to use these two equations for converting revolution per minute to radian per second. So let's find the answer for radian per second. So omega I, which is equal to 200 revolution per minute. First I'm going to make the conversion for revolution to radian. So I have to make the revolution in the bottom. By that we can cancel revolution with this revolution. So 1 revolution, which is equal to 2 pi rad. And then I have to convert the minute to second. So for that we need the seconds in the bottom. By that only we can get the unit in terms of radian per second. So how I can write 1 minute, which is equal to 60 seconds. Now you can see a revolution get cancelled with this revolution, the unit, and then we can cancel minute with minute, and then we can get the answer of omega I in terms of now radian per second. So here, when I just multiply 200 with 2 pi and then divide by 60, here I got the answer as 20.94. 20.94. Now what is the unit? Radian per second. So this is the answer for the first question, because they need the answer in terms of radians per second. So we got the answer for the first question of 200 revolution per minute in terms of radian per second. So for radian per second, what answer we got? 20.94. Now we have to come back for the second question. What is given in the second question? What is the linear speed of a point on the rim of the flywheel? In theory, we studied the relation between the angular speed and the linear speed. So what's the rule for that? V, which is equal to R omega. So here we have to use this omega. So I can write R multiplied by omega I. This is the relation between the linear speed and the angular speed. Here the linear speed is V, angular speed is omega I. Now I have to use the radius, which is already given, because the diameter, from the diameter we already find the answer of the radius. So what is our radius here? 0.6 meter. So I have to use that number here. So 0.6 multiply with 20.94. I got the answer for the linear speed as 12.56. 12.56. What's the unit? Meter per second. So this is the answer for the second part, B, right? Now we have to go to the third part, C question. What is given in the C question? What constant angular acceleration will increase the wheel angular speed to 1000 revolution per minute in 60 seconds? But we have to give the answer of this angular acceleration alpha value in terms of revolution per minute square. So we don't need to convert our angular speed because it's already given in terms of revolution per minute, but only we have to convert the time from 60 seconds to minute. So because we know 1 minute which is equal to 60 seconds. So for the third part, let's rewrite the given one more time. For third part, what is given in the question? Omega I, which is already given as 200 revolution per minute. We no need to convert. And then your angular speed has the final value as 1000 revolution per minute, which is already given in the question. And also they gave the time, which is 60 seconds. If you want to give the answer for alpha in terms of revolution per minute square, we have to convert that second to minute. So 60 seconds, which is equal to how many minutes? 1 minute. Now you can see by using this omega I, which is angular speed initial, angular speed final, and then by using the time, we can easily find the angular acceleration. And for sure, our unit should be in terms of revolution per minute square. Why? Because in the question, they clearly mention you have to find the answer of alpha in terms of revolution per minute square. So for that, I have to use the equations of motion with constant angular acceleration. And I am going to use the first equation. What is our first equation? Omega final, which is equal to omega initial plus alpha t. And we are going to find the alpha, which is angular acceleration. So alpha, which is equal to omega final minus omega initial divided by time. I'm going to substitute the value here. Omega final is 1000 revolution per minute, right? Minus, and our initial angular speed, which is 200 revolution per minute. And then what is our time, which is 1 minute. So you can see revolution per minute square. So our answer will come in terms of revolution per minute square. So now we have to subtract 1000 with 200. So what we will get the answer for alpha? The answer for alpha, which is 1000 minus 200, which is 800 revolution per minute square. So this is the answer for the third part. Clear? Now we have to go back to the question. Let's read the fourth part because this question has 4 subdivisions. How many revolution does the wheel makes during this 60 seconds? So in this 60 seconds, how many revolution this wheel make? That means we have to find the value for delta theta, correct? Because our delta theta is nothing but the revolution value. So for the fourth part, which is our D part, we have to find the value of delta theta. And we can use the same thing. Omega I, which is equal to 200 revolution per minute, and omega final, which is 800, sorry, not 800, which is 1000 revolution per minute. And then alpha in the previous part, we found the answer as 800 revolution per minute square, and also the time in 60 seconds. So 60 seconds, which is equal to 1 minute. So now for finding this delta theta, we have to use the second equation. What is our second equation? So our second equation is delta theta, which is equal to omega initial multiplied by t, right, plus half alpha t square. This is the rule. This is the equation, second equation. Now what I'm going to do, I'm going to substitute the value for finding the answer for delta theta. So let's substitute the value. So what is our omega I? 200 revolution per minute multiplied by, because we have the t, which is 1 minute, plus half alpha value. In the previous part we got 800 revolution per minute square, right? And then t square, which is nothing but 1 minute square. So we can see here, we can easily cancel minute with minute. And likewise, minute square with minute square, we can easily cancel. And then we can cancel this 800. So if you divide 800 by 2, we'll get 400. So now we got 200 revolution per plus 400 revolution. So what's the total? We can easily add. So therefore delta theta, which is equal to 600 revolution. So that's the answer for our fourth part. Clear? So this is the answer for this question. That's it. Thank you.